Welcome to SanfordFlipMath. This is Algebra 2. We are still diligently working through the Springboard book, and we are currently in what they would call Activity 25, and we are solving, this video is about solving square root and cube root equations, and so we're going to do some of that. And basically, just a reminder that when you're solving, as you already know, basically you want to be thinking about what undoes something. So just like multiplication undoes division and division undoes multiplication, addition and subtraction, we've done some square rooting to undo squaring, and all we're really going to do this time is do some squaring to undo square rooting. So for instance, I'm trying to get x by itself. That's the goal, is find the values that make it true, and by getting x by itself, we will do that. So I'm going to square both sides, and so this just becomes x equals 16. And if we're going to check that, we would say, hey, the square root of 16, well, I guess that's 4, so I guess it actually worked. Okay. One thing I need to make note of, and that we haven't really talked much about, is an alternate notation. And so square root can be written as 1/2 power. So one thing to make a big deal out of, this does not mean times 1/2, and that same idea, so like the original equation I wrote here could have been written like that. And if I raise both sides to the second power, so when you raise a base to an exponent and then another exponent, if you recall, you multiply exponents. So if I do 1/2 times 2, that's 1. This becomes x to the 1, or x equals 16. So there's absolutely nothing different about that. And so let me just kind of make a little note off to the side. If I have a base raised to a fractional power, then what that actually is equal to is the base inside the radical, the square root symbol, only in this case it's the nth root. Okay, so this n is this n, just like this, oh, I don't like that color, sorry. Just like this 3. So like this particular one could be written x to the 1/3 power equals 4. So cube root of x is 1/3 power. Okay, so let's back up, and what we're going to do is solve this little guy. Okay, so cube root of x, well, remember, cube root means what was cubed. Third root means what was raised to the 3rd power. Well, to undo that, I'm just going to re-raise it to the 3rd power, so on both sides, I'm going to cube. So the cube root of x cubed is x, and 4 to the 3rd is 4 times 4 times 4, which is 64. Okay, and that would look really the same if we were doing 1/3 power. So if I do to the 3rd power, again, 1/3 times 3 is 1, so this is x to the 1, or in other words, just x, which is 64. Okay, so nothing too crazy. I have some notes here on the side that just some general thoughts on solving, and those are really, when you're talking about a one-step equation like what we just did, both of these were one-step equations. We just squared both sides or cubed both sides and we were done. That's really not such a big deal, these thoughts. However, when things get a little more interesting, then it's more of an issue. Okay, so here we are. And again, we're going to do kind of a matching square root and cube root equation, just so we get the idea of what's going on. Okay. All right, so here we go. Remember that you're trying to reverse the order of operations because you're trying to peel things off in the opposite order. I know in class I make a big stink about, that's funny, stink, shoes and socks. But the idea is when you're putting them on, you start with your foot, and then you put socks around your foot, and sockies, yeah, and then you put shoes around them. So when you're trying to take those things off, you have to, when you get back to your foot, you have to take the shoes off first. Wow, that was amazing. That didn't work exactly how I expected it to. You have to take the shoes off first, and 7, something like that. And then you have to take the socks off, and then you get back to your foot. Okay, so whatever went on last has to come off first. So in other words, reverse the order of operations. Okay, so for instance, as I look at this x, I know that by order of operations, I should be subtracting 3 first. So the minus 3 should be first. And then I would be doing the square root. And then I would do the 2. And then my answer then would be 4. So as I am solving for x, I'm going to undo them backwards. I'm going to undo the 2. Then I'm going to undo the squared. And then I'm going to undo the subtraction. Okay. All right, so let's do that. So let's undo the outside thing first. So we're going to divide both sides by 2. Okay, and then I need to square both sides to undo the squaring. So this is now the square root squared just cancels out the square root. Okay, and then I need to get, again, all of this is about getting x by itself, so I'm going to add 3 to both sides. And so x equals 7. Okay, now just to check that, I could actually put that 7 back into the original equation. 7 minus 3 is 4. The square root of 4 is 2. 2 times 2 is 4, so it actually worked. Okay. All right, so let's do the exact same thing again, only this time we're going to work with the cube root equation. And again, whatever's on the outside has to be dealt with first. Okay, and then we're going to, so let's rewrite that cube root. Okay. And then we're going to, now would I square both sides? We're really going to cube both sides. Okay, so when I cube, this becomes x minus 3 equals 8. This is not 2 times 3. This is 2 times 2 times 2. Okay, 2 times 2 is 4, times 2 is 8. Okay, and then we're going to add 3 to both sides. So x equals 11. Okay, now again, let's just take a hot second and check this. 2 times the cube root of 11 minus 3 equals 4. Well, 11 minus 3 is 8. I'm supposed to do stuff on the inside first. Well, we're hoping it's equal to 4. How about that? Okay, and then the cube root of 8 is saying what was cubed. So in other words, what times itself is 8, and shockingly enough, that happens to be 2. And 2 times 2 is 4. And that's what we had at the original equation, so yep, that worked. Okay. All right, I would like to do just a couple more examples. There is a little bit of an issue that comes up. You know, there's always an issue that comes up. Okay, and then we'll be done. So last slide, last page. Okay. And again, we're going to do matching problems as we have. Okay, now big warning. This 2 is connected to this by multiplication. This 5 is connected to this 2 by addition. Well, this 2 being connected here makes this basically like one big term. It's supposed to be an R in there. Okay, now these are not like terms. And I say all that to say this. Don't add the 5 and the 2. Okay? This is not 7 times the square root of x minus 3 equals 4. It is not. This is not 7. Okay, you cannot add the 5. It doesn't have a square root of x minus 3 with it. So these are not like terms. You can't add them. Just like you cannot add 5 plus 2x and call that 7x. Same way. Okay, same thing. All right. So that's just that's really not what this is about, but that's just a word of warning because that happens fairly often. So please be careful. Okay. So again, things, shoes, and socks. Pull off the last thing first. The last thing, you know, if we were going to do a calculation, if we were going to put an x value in, we would subtract first, then we would do the square root, then we would multiply because multiplication comes before addition, and then we would finally add. So we're peeling off from the outside. Okay, that's the idea as far as what's going on here. Okay. All right, so wait, let me get that last little, there we go. All right, so what we're going to undo first is the last thing. We're going to undo the addition. Okay, so this becomes 2 times the square root of equals -1. Okay, and then we're going to divide both sides by 2. Contrary to popular belief, 1 divided by 2 is not 2. It's 1/2. So this is -1/2. Okay, 1 divided by 2 is not 2. 2 divided by 1 is 2. Okay, sorry, I've just been seeing some of that lately, and it's scaring the bejeebies out of me. All right, undo the squaring, or the square rooting by squaring. Okay, so this becomes x minus 3 equals, well, negative times a negative is positive. 1/2 times 1/2 is 1/4. So this is x equals 3 and 1/4 once I add 3 to both sides. Sorry, I didn't show that step. Or if you would prefer, 13/4. Now, there's a big but coming. I know that's terrifying, but here it comes. When we are solving square roots, fourth roots, sixth roots, even roots, it is possible to get what are called extraneous solutions or extraneous roots. We dealt with those back when we were solving absolute value equations back toward the very beginning of the year. But remember, an extraneous solution is basically a solution that is extra and erroneous. I think there are 2 R's for this one. In other words, wrong. Well, that's what happened just now. This really doesn't work. Well, how do you know that, Mr. Sanford? Well, browse the selection and find something that doesn't make sense. Okay, I will help you out, just in case. Some of you already found it, and I'm very happy about that. Okay, I want you to look at this little step right here. Wouldn't this have to imply that the answer from this square root would have to be negative? The only way that the answer from a square root is negative is if there's a negative sign on the outside of the square root. And there isn't one. There isn't a negative here. So, or if you prefer this other step, okay, here it is, a square root equaling a negative. Not POSA happened, not supposed to be. Okay. Now, how can you know that that happened? Well, you can know that happened by putting your solution back in. And this is ultimately what needs to happen is you need to, when you are solving square root, fourth root, sixth root equations, you need to check. Okay, and I know with a fraction this is not so nice. I'm sorry, real life happens sometimes. 5 plus 2 times the square root of, so I'm going to do 3 1/4 minus 3, and my hope is that this equals 4. Okay, again, start on the inside, so this becomes 5 plus 2 times the square root of 1/4. Okay, so 5 plus 2 times, well, the square root of 1 is 1. The square root of 4 is 2. So this becomes 5 plus 1, which is not 4. If during this process this would have been a negative, then 5 minus 1 would have worked, 5 minus 1. And that's ultimately where this came from, is because of the negative that happened when we were kind of playing around with the solving. Okay, so what does that mean for us? The only solution we got wasn't a solution. So the answer for this particular one is really no solution. Now, please note, this only happens when we're talking about square roots, fourth roots, sixth roots, eighth roots, and even roots, okay? Remember from our playing around with cube roots, you can cube root a negative and get a negative answer. That's legit. You can cube a negative number, you will get a negative answer from that. Okay, so as I'm solving this one, So this becomes 2 times the cube root of x minus 3 equals -1. When I divide both sides by 2, I still get a negative in here. Cube roots can be negative. That actually happens. Okay. So now when I cube both sides, this becomes x minus 3 equals -1/8. And then if I add 3 to both sides, you're not going to like this because, yes, it involves the F word, fractions. So this is a positive 3 minus 1/8, also known as 24/8. That's 3 minus 1/8 equals 23/8. Or if you would prefer, 2 7/8. Okay. Not saying there's going to be a lot of work with fractions, but in real life, fractions happen. So there it is. All right, so the short version is this. You have to peel things off of the outside, working your way back to x. Just a word of warning about combining things that aren't like terms. Don't do that. So we peeled off the 5 by subtracting. We divided by 2. Anything on the outside of the square root, on the outside of the cube root. A lot of math teachers say isolate the square root, isolate the cube root. That works. When we did this with absolute value, again, back in like September, October, we isolated the absolute value. We got everything off of the outside of it. Well, we're doing the exact same thing. It's just instead of undoing absolute value and doing the plus or minus thing, we're undoing square root by squaring, or undoing cube root by cubing, or undoing fourth root by raising to the 4th power. And again, one last thing, one last reminder, this equation that we just played with could have been written 5 plus 2 times. And this would have been the same thing as our original equation. So just a little reminder that, you know, we're adding some notation in here that you may or may not have seen before. Okay, so any kind of roots can be written as a fraction. Okay, so b to the 1 over n equals the nth root of b. Same thing. Okay. All right. Well, thanks for watching. This has been SanfordFlipMath. Lovely spending time with you wherever you may be. Have a great one. Bye bye.